I'll be sharing or presenting the ORAN use cases. So when you say use cases, parang ano ba yung purpose mo sa buhay? Tapos ano yung mga pwede mo pang gawin with that purpose? So the ORAN Alliance has these use cases. Kumbaga, it drives them to go with the movement because it will help in the betterment of the industry. So, ano-ano ba itong mga use cases na to? Okay, so let's go with the ORAN technical priorities. So, I think familiar naman tayo sa mga nasa telco, familiar tayo with the 3GPP. Basically, nung magsimulang magkaroon ng G, actually nung 1G nga parang wala pang usap-usap nun eh, kanya-kanya. So may kanya-kanya silang what do you call this? Kanya-kanya silang specifications. Syempre, it's a geopolitical decision and action. So may sa North America, meron sa Asia, meron din sa Europe. Pero usually ang nagtatalo talaga dati is either European standard or North American or the US. So ginasabi ng North American, US standard. Or makita naman natin yan eh kasi may metric tayo, meron tayo English. So may ganung factor para magkaroon ng standardization. So, nung nagkaroon na ng mga G, 1G, 2G, 3G, yan, start na, especially when it was the time for the 3G, is to sit down and discuss specifications. Bakit ba kailangan ng specifications? It's because kailangan pare-pareho tayo, same wavelength tayo. I mean, pag sa barkada or sa isang grupo, kailangan pare-pareho tayo ng iniisip. Kung kakatingin na lang tayo, alam na natin na gano'n ang mangyayari. So, gano'n na nangyari dito sa telecom or specifically sa cellular technology with the advent of the 3GPP. So, may specifications dapat pare-pareho. So, if you're in the telco industry, regardless of your vendor, iisa lang niyang may kanya-kanya silang tawag, may kanya-kanya silang arte sa mga parameters and all these terminologies, but basically they're under single specification dahil may 3GPP. So nag-uusap-usap muna lahat at yun ang susundin. Ngayon, kung hindi ka susunod doon, out ka. Kasi di ba, hindi kakapareho nila. So in this regard, ORAN technical priorities is parang a guiding principle or what do you call this? I think it's a goal. I mean, it's what they're targeting to achieve. So the Open RAN technical priorities, are mostly by the European operators. Sila yung unang umupo para pag-usapan ang technical building blocks, requirements for the Open RAN. And it's basically put into 10 requirements. So makita natin dito, you have the OCloud infrastructure. So a Kubernetes-based OCloud platform supporting the necessary RAN software shall be that mainstream implementation. So one thing I want to emphasize here is the cloud. I mean, it's that era or it's that age that we're already migrating into the cloud. Before may kanya-kanya tayong mga hardware, meron tayong mga monolithic hardware na hiwa-hiwalay. And then we're basically lahat, hindi lang sa telco lahat ng infrastructure are going into the cloud kasi it's cheaper, it's scalable. I mean, andaling magpalaki ng isang infrastructure with the cloud. And nawala. Okay, yan. So, isa yan sa mga requirements in the Open RAN. And iyan yung isa sa pagkakaiba niya with the traditional RAN that we are going to the cloud. So, another requirement would be the OCU and ODU. So, sa mga nasa telecom, you will be familiarized with the centralized unit and the distributed unit. So, this is part of the radio access network na ni-split lang. So, same lang. Wala naman silang binago dun eh. Nilagyan na nila ng O to denote that it's Open LAN, but it's basically the same. So you have the RRC in the CU, and then you have the MAC layer in the DU. So ginawa mo lang part of the Open LAN. So you have the OCU and ODU. So implemented as CNFs on power efficient and reliable GPP CPUs with hardware acceleration support for 0DU processing. GPP is a general processing hardware. I mean, since it's Open LAN, it can be any white box hardware na pwede mong lagyan ng software na open sa lahat. Kasi ngayon, ang implementation is that if you are vendor A or vendor B, may kanya-kanya silang implementation. So, yan, isa sa mga requirement nila na kailangang tutukan. And then, you have the ORU, okay? Ease of deployment and operation is key, facilitated by multi-band and AAUs, both with low weight and high power efficiency. So, ito yung radio unit, okay? So, I think nakuha nyo naman to with the first session, introduction of Open LAN. So, you have the idea of the architecture. So, we have the open front hall. So, ito part din ng Open LAN is to open the front hall. So, ito rin isa sa mga requirements nila. Basically, ito kasi is pinag-iwahiwalay para alam mo yun, merong kang, yung mga team O-Cloud dito, team OCU, team ORU. So, may kanya-kanyang pag-uusap yan. Okay? Para hindi magulo. At least para iisa lang yun. May mga experts sa mga ganito, dito sila mag-uusap-usap. So, the open front hall, HIOT profile specified in the O-RAN Alliance are key for the operators. And then the main RAN features, okay? So pag dito naman yung both 4G and 5G are targeted based on both NSA and SA architecture for single operator and RAN sharing scenarios. So makikita nyo all throughout the discussion on Open RAN is that it's lagging 4G and specifically 5G. Bakit? Kasi Open LAN can be on all Gs. But alam niyo, kung magsisimula ka ngayong mag-roll out with using Open LAN, I think it's 5G na. Kumbaga kasi, operators around the world are shutting down lower or legacy generations. So, may mga countries na wala ng 2G and they're starting to shut down 3G. So, it's cost efficient if kung magkakaroon man ng Open LAN in the nearest future, it's more on the 5G kasi ito na yung kasi meron na rin 6G din develop eh. So, yun, parang okay operator, sa 5G na tayo mag-start. So, and then NSA, non-standalone, and standalone. These are terms for 5G. So sa mga nakakaalam, yung 5G kasi later on na nag-start, di ba? And nakapag-gumastos na ang mga operators with the 4G. So parang gagastos na naman tayo, 5G, pang 5G, may 6G na naman, alam mo yun, parang phone lang yan eh. Pero tayo, minsan, hindi natin afford bumili ng phone agad-agad. So what happens sa mga operators naman is paano ba natin magiging hindi tayo masyadong magastos? So, na-develop nila yung non-standalone, meaning the 5G is not standalone. I mean, hindi siya nag-iisang entity or nag-iisang infrastructure. 5G is, I'm not saying piggybacking, but it gets the help from the 4G. You anchor with the 4G kasi nandiyan na yung infrastructure gawa na eh. So ina-add mo lang yung 5G para magkaroon ka ng additional throughput, additional bandwidth. Tapos makikita mo sa signal bar ng mga tao, 5G na ako. And currently in the country, we're using non-standalone. Okay? Although some countries or some operators in different countries are using SA but pull out na and siguro hindi pa nila nababawi yun. Let's go with the non-standalone and later makikita natin. I'm not sure with other operator, may bagong operator tayo eh. So I'm not sure if they're already using standalone. So your guess is as good as mine. So mga na yung mga participants natin na maybe working with the new telco, maybe you know na kung ano na ang ginagamit nyo. So anyway, and then the sixth requirement would be the RIC. So this is the new addition. Wala to sa traditional RAN. So basically meron siya dapat sariling block dito. So the RIC should bring enhancement in terms of intelligence and programmability. Okay. So yan yung wala natin sa traditional RAN. And then you have of course these are all hardwares, no? And then dinagdagan pa nila ng different blocks to discuss about automation, okay, that will happen in the SMO. So you have the service management and orchestration. Vendor shall adopt a unified data and information model to increase service management efficiency. So this is sila mag-uusap. Energy efficiency, hardware should be the most energy efficient as possible, starting with radio transmitter. You know, energy efficiency lagi itong pinag-uusapan eh. Pag may mga projects ako sa iba't ibang operators, even before, ang gusto nila yung mga features, yung mga traditional RAN vendors natin, they have the energy efficiency features na usually laging binibili ng mga operators kasi gusto nila na walang gastos masyado sa kuryente because, you know, base stations or the cell sites, may kuryente yan, kumakain ng kuryente. So they want energy efficiency. And I think this is also driven by the, what do you call that protocol? May protocol kasi parang about environment inside European, nalimutan ko na if ever anyone can maybe share. But parang kailangan maging green tayo. So dapat una kailangan natin i-reduce yung carbon footprint natin. So the energy efficiency is mahalagang feature na hindi pwedeng iwanan ni Open RAN. So kailangan may sarili silang discussion dito. So hardware should be the most energy efficient as possible. And then of course, security. Ito yung isa sa major or isa sa mga nagiging adamant ang mga gustong mag adopt ng Open RAN. Is that security? Is it secure? Kasi alam mo naman sa panahon ngayon, this is paramount na kailangan we feel that we are secure. So a global priority for the operators requiring strict policies and features across all entities of the Open RAN network. And I think this would be the next session. Meron tong separate discussion and there is a separate expert that would share his or her experience about security. So yan. And then the last block would be the high availability. So a key requirement to ensure the expected reliability of the operators' networks and services encompassing domains of Open RAN. So high availability meaning dapat laging available yung site, walang downtime. Okay, so yan. Take a look. So ito yung mga technical building blocks na napag-usapan ng mga European operators. So ito yan, sina Deutsche Telekom, sina Orange, TIM, and then Vodafone. So siguro magiinuman sila tapos mga pare ano pag-uusapan natin yan. So siguro ako pag-usapan nila. Okay, so next. Yan, okay. So ito medyo na technical but I just want to show you yung document ito. So kailangan, you know, documentation is very essential in telecommunications kasi kailangan napag-usapan nyo, kailangan isulat nyo. So para lang memorandum. Para lang din siyang means of the meeting na nilagay nyo into formal document. So you have this Open RAN technical priority document. I think this is public. You can search it online if you want to go. Yung mga, alam ko may mga tao na ginagawang pampatulog yung 3GPP, binabasa. So maybe ito, pandagdag nyo sa light reading, the Open RAN technical priority document. So yan, makikita nyo dito yung mga, may mga priority levels. Kasi sa dami ng kapag-usapan nila, ng mga areas where to focus. So you have to put priorities. So P0, ito yung mga must-have, shall support. I think mostly lahat ng nilagay dito is yung mga, syempre, kailangan priority level, yung mga ino-offer niya ni traditional RAN. I mean, if you're going into Open RAN, dapat yung nagagawa ng traditional RAN is nagagawa rin ng Open RAN. So, I think lahat ng mga nagagawa ng traditional RAN, nilagay nila ng priority 0. Kasi kung magbebenta ka nga naman ng isang bagong framework para sa implementation, you have to tapatan mo lang yung nagagawa ng previous or better. And then you have the P1. So, nice to have. So, ito yung mga kaya ba yan ng lolo mo, di ba? So, ito yung mga yan. So, they put that into different priorities. And then I have the priority type. You have the unanimity, the majority, and the minority. So, ayan yung kumbaga parang pinagbobotohan ng mga operators. Okay? So, ito gusto namin to. Huwag na yan. 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 So, sige, buksan natin para I have an idea. Wait. Hindi ko pala nakiklik to. Okay, anyway, you can search it on, medyo magiging information overload tayo dito pag tinignan pa natin to. Okay, ito pala. Nanito pala yan. Siguro, tingnan lang natin in an overview. So you have the topics here. Yan, you'll see that you have the priority 0 here for ito, RAN sharing, mock, and it's being used now with a traditional RAN. So they made it priority 0, but not all, or the priority type is minority. So let's see a P0 unanimity. Ito, okay. So they made it priority support of ORU and virtual DU, CU on site with open front hall. Ayan. Kumbaga parang, sige, unahin natin to, gusto ng lahat. Okay? Then, saan ba ito? RAN sharing, majority, support of shared. Saan ba yung ano natin? Pointer. Okay. Support of shared RU and dedicated VDU per operator. On-site with open front hall, all the same infra and centralized DCU, different edge regional clouds. So, yung mga requirements. So, if you go into the technical details or the technical priorities, and you want to delve deeper into that, so makikita nyo dito ano-ano yung mga priority. So, at least you have an idea what would be the landscape in the coming years. Kasi alam nyo kung ano yung mga pinaprioritize nila. Okay. So, yan. Okay. Technical priority, scenarios. Okay. And then, you have the RIC use cases. Okay. So, since we know that RIC is programmable, so dito ngayon ilalagay yung mga, kumbaga, because it's programmable, we can apply artificial intelligence and machine learning. And alam mo, this is the trend now na everything would be I should think that people should still drive the technology, but AI is there to help, to make it faster, to make it efficient, and alam mo, minsan parang nakakatamad na rin mag-isip. So at least the AI would do some of the processing. So itong mga use cases natin pag-uusapan ngayon, yan, naka-include din yan sa technical priorities. Okay? And the reason why we chose these topics is because they are part of the priority levels. So, kumbaga, for sure, meron ito, okay, in the coming years, because they are priority 0 and the priority type is unanimous. Okay, so pag-uusapan natin, traffic steering, massive MIMO. Okay? Questions po? Teka, tingnan natin, chat. Baka kasi masyado. Ayun, nagsabi, sustainable development. Thank you, Sir Rodel. Yan yung inaano ko kanina. Kasi yan, tama. Ayan, sustainable development goals. Yes. Actually, hindi lang naman sa telecom yun eh. Ano to? Teka, marami pa mga comments. Sorry. 5 or 6G NSA ng standalone pa lang. I'm not sure what you're telling, but maybe this is pertaining to the new operator. Ayoko kasi mang name drop eh, baka mademanda tayo. So anyway, non-standalone pa lang. Baka, okay? So yun nga, alam ko nga non-standalone pa lang mostly for the operator. Sustainable development goals. Okay. So wala pong questions. Let's go. Ayun. Okay. Okay. So let's go over, before we go to the use cases, kwentuhan muna tayo about let's have a review on the radio access network, antenna theory. Okay? Ito yung mga ito throwback natin sa 4 years or 5 years natin sa college. Okay? Okay, let's go first with the run overview. So para may idea kayo mamaya. And I think madami kanina nagsabi na sa telco sila eh. So parang baka antukin kayo dito and medyo alam nyo na. So pero pag-usapan natin. Okay? Radio access overview. Our radio access network overview, I think you have discussed it in the introduction. So let's go back again kasi that's 2 sessions ago. So basically, radio access network is the cell site. Okay? Yung mga nakikita niyo mga towers or nasa buildings. And you'll see here that you have the baseband unit, you have do the computations here, and the radio remote unit, you have the practically the physical layer here, the layer 1. So dito yung mga modulation nyo, dito what do you call it? Hindi computation eh. You're processing, processing the information here before you send it to the transducer or to the antenna. Okay. So we convert the digital signal into the analog. Kasi walang digital signal ang tumatakbo sa air. So it should be analog. Kasi yun ang physics niyan, di ba? If you go to Comms 101, yun yun. So you have the baseband unit, computation, and then you have the RRU. Kung narinig yung term na RRU, that would be the radio remote unit, and you have the antennas. So makikita niyo dito, kaya pag nakakita kayo ng antenna, ganyan, basically ang itsura talaga ngayon, panahon ngayon. Medyo komplikado na. Nung unang panahon kasi, you'll just have one antenna and then wala kang makikitang RRU because the radio unit and the baseband would be in the cabinet. Okay, that would be the 2G era. So ngayon, you have, ang dami mo na kasing spectrum eh. So different bands, different antenna, okay, low bands, and the high band. And then you have the microwave. So hindi natin naanhin yan. And, communication lang yan for the different base stations. Okay. So let's go, hindi natin pag-usapan baseband unit, we go the radio remote unit. So punta tayo sa nung nagbubuga na ang antenna. So kasi mamaya malalaman natin bakit need natin itong malaman. So if you go back to our antenna theory, pag bumubuga ang isang antenna, you have the main beam and you have the side loads. Paano natin i-discuss to? Di ba, if you go to, I'm not sure anong subject natin to nung college, but if you, the wave theory, if you agitate the nature, magkakaroon yan ng reaction, and that yung reaction ay yung waves. So if you have, pag pumunta ka ng tubig, tumalong ka, or nagbato ka ng bato, magkakaroon siya ng wave sa tubig, di ba? Or ito, nagsasalita ako, it's a wave. The reason why you're hearing me is because of the wave generated by me speaking, right? And then you have the magnetic spectrum, okay? So if you agitate a transducer, it creates a wave. And it's the same with this. So ina-agitate ito with the help of the baseband unit and the radio remote unit para mag-send ng tinatawag nating signal. So pag sinasabing wala akong signal, ito yun. So pag bumubuga siya, you have the main beam, and mamaya makikita natin bakit ganito ang itsura, because you're creating directionality because of some factors. And ang gusto ko lang i-point dito is yung term na half power point is where you basically have the power reduced to half of it. Okay? So bakit when tinatawag na neg 3 dB? If you remember logarithm, if we log of value, pag kinalahati ninyo is 3 dB. So if for example, if you have 40 watts and then ginawa yung 20 watts, log nyo yun is basically you have like, ano ba ang 20 watts? It's 43, I think, 46. And then, meron akong calculator dito eh. Share natin to. Share. Okay. Kita niyo po ba to? Okay. So let's go. Here, you have 40 watts. 46, tama. Okay, you have 46 dBm. So log of 40 times 10 would be 46. And then if kalahatiin yung 40 would be 20, you have 43. So 46 minus 43 would be 3 dB. Okay? Let's go back on that. Yun. So ito yung makikita nyo sa mga nasa telco, ito yung tinatawag natin na main lobe. So ito, pag ang phone mo is andito ka. Yan. You're in the main beam. So most probably, or not most probably, for sure, makakatawag ka, makakapag-data ka, and you have the highest or you have higher throughput compared when you're in the side lobe or side lobes and null points. Okay? Or tayo gumalaw nito. Ayan. Sorry. Okay. So pag nandito ka sa null point, ito yung mga, ay, wala na akong signal. And bakit may side lobe? Because theoretically, we should be seeing like ito lang, okay? May directionality. But in real world, hindi mo masasuppress talaga tong side lobe. So you'll be creating this side lobes, and this for some of you in the telco is a bit of a problem sometimes, okay? Na nagki-create ng some like interference or intermodulation. So okay, yun. Okay, main beam, and then okay. So if we go when we talk about the radio access network, we're talking about cellular technology, and from 2G onwards is kaya siya tinawag na cellular is because of the cell, and theoretically the design should be like this. So you have the hexadecimal. You have the what they call this? Hexagons. Hexadecimal, sorry. Hexagons here. Ito yung design natin because it is the most effective way of creating patterns. Okay? Because if you have this technology, hindi na pwedeng isang antenna lang because due to fading, hanggang dito lang talaga maaabot na pag bumbuga ka, hanggang dito lang talaga because it would fade. We have multipath fading. So kailangan mong i-design yung network para lumaki to have different cells. So in rural areas, hiwa-hiwalay ang mga antennas. In urbans, lumiliit hanggang sa maging dense urban area. So yan. This is theoretical. So in real life, hindi ganito ang magiging itsura niyan, pero at least you have the guiding principle na ganito dapat ang design ng cellular network. So for example, andito ka sa isang area, lilipat ka dito, you'll be served by a different base station, and you have mobility, handover, reselection to a different base station while you're moving. And to look it simply, you have two base stations. You have the signal sent here on the y-axis, and then you have the signal sent for the site B. So as you go away from the site, due to fading, hihina yan, hihina to the farm. Kung wala, kunyari, imagine niyo wala yung site B, okay? Hihina hanggang sa you'll be either dropped or you cannot access the network. So the idea is to have to have a seamless connection. So as you go below the level, dapat may sasalo. That's why you have this design is to have the next neighbor or the next site for you to be handed off or reselected to. So pag humina ka na may some point dito na ganitong level, kanina nakita ko sa pre-test na level RSRP na the signal sent of the site, yun yung ginagamit na indicator, ni-report kasi na phone yan, na ganito na lang ako. So alam mo yun, kailangan ko na ng next. Kung hindi, madadrop na ako. So, yun yung threshold. Pag nakita niya ni network na gano'n na, so the decision, actually, in the traditional run, may decisions na rin eh. Nagde-decide na rin yan dito, nagko-compute. Pag nakita niya na neg 93 na lang ako, neg 93 dBm, so I have to find a suitable neighbor para pagpasahan, para tuloy-tuloy ang buhay natin. So, kasi pag nawala na yung signal, di ba, parang ang lungkot. So, ngayon sa mga panahon ngayon. So, you have to have that point. And then, pag na-hand off ka na, okay, tuloy-tuloy uli ang ligaya natin hanggang lumakas ka uli, hanggang sa lumipat ka na naman, and so on and so forth. So, ganyan yan. And here, we'll see the different Gs, 2G, and you see the dates, and the years, kung kailan nagsimula. We have the 3G, 5G, nagiging more on data tayo. Okay? Nawawala na yung development for the voice kasi wala na rin naman masyado na kailangan i-develop with the CS kasi we're slowly transitioning into data IP-based and even the calls are IP-based. I mean, may mga tumatawa pa ba sa inyo sa phone? I mean, people are either calling you with Viber or calling you with WhatsApp, calling you with Messenger. Actually, mas tipid kasi you're just buying the data load. You don't have to buy the all net call, di ba? So yeah, slowly transitioning into it. So wala na masyado after the 3G, wala na masyado on the CS kasi you have the VoLTE na for the 4G and it's all IP and then the 5G and so on. 6G and hanggang ugod-ugod tayo, I don't know, hanggang saan natin maabutan yung G na yan. Okay? So for me, I think when you're going into higher generation, ang pinagtatalunan na lang ngayon is the latency and the throughput. Okay? Parang ngayon nga ang parang 10 Mbps parang ang kulang na Okay? Pero noon parang masaya ka na with 300 kbps. Okay? Even for the dial-up, wala na ngayon ganun. Pero ngayon nagkukulang na yung throughput, yung bilis. Bakit? It's because of the payload. Tumataas na rin yung payload. Wala naman kasing contents before, di ba? Our contents before are in print ads, on the books, di ba? Mayroon ka mga song hits before. Lahat ng lyrics nandoon. So you don't have to look into the World Wide Web. Pero ngayon, as it progresses, yung tinatawag nila na network effect. So tumataas yung demand for the bandwidth because tumataas din yung mga lahat ng information na nilalagay na natin online. Pati buhay natin nasa online na, di ba? So before dati wala So kaya parang hindi tayo naging satisfied sa throughput because tumataas din yung requirement natin. Okay, any questions po? Let's see. Okay, good morning. Okay. Honeycomb, yeah. Okay, question po dito. So at least ito lang overview. Ito lang yung mga I think na kailangan yung ma-refresh para sa discussion natin with the use cases. So if you don't have any more question, let's go. Gumalaw. Next. Okay, so measurement quantities. Basically, it's showing us for us just an overview. I know there are a lot for some telco professionals here. I know there are a lot of measurement, but for the sake of our brothers and sisters na medyo hindi naman sa telecom, let's just focus on these three: RSRP, the RSRQ, and the SINR. Doon po sa mga tawag dito nag-i-efficacy oil na ngayon, siguro maabutan nyo pa yung RX level and RX quality. So basically ito rin yung mga yon. So that's in the 2G. So ano ba yung mga yon? Ano ba to? Higher data rate, higher window for hackers. Yeah. I mean, ano yung sa panahon ngayon, kahit anong technology, may paraan pa rin yung mga kawatan. So wala talaga tayong magagawa. Kaya nga yung discussion on the security is important on the next session. So that would help us mitigate this problem. Okay, measurement. So you have the RSRP. Basically, this is the received power. So ito yung coverage. Ito yung coverage natin. Okay? Ito yung, paano ko ba sabihin? Para sa mga layman, yung nakita mong signal bar sa phone, that would correspond to the signal level. And that would be basically the RSRP. Okay? The reference signal received power. Meron po ba dito? Okay. Sir, are those values for 4G or 5G? This is for 5G. Okay, 5G, 5G. So because you have the SS and then the CSI. CSI. Okay. There's still use this differentiate you the LTE. Tawag you still call it RSRP, RSRQ, and SINR. You go to 3G, you have the RSCP and the ano nga ba yun? RSCP and ECNO. Okay. And then you go to the 2G, you have the RX level and the RX quality. So basically, you're just saying that this is your receive power, this is your coverage. RSRQ, reference signal receive quality for the quality, and then the signal to noise interference ratio for the SINR. So you have the coverage because you have to kailangan bumuga ng RAN. Okay? It needs to propagate, and a way for it to be known. I mean, nung unang panahon before, simple lang ang buhay. I mean, the transmitter would transmit, bubuga yan, and then pick up ng phone. Okay? And then yun na, mag-uusap na sila. Pero with the latest technology as week progresses on, nagiging komplikado na to the point na need na mag-synchronize ng UE para alam nila hindi mawala. Kasi pag nawala ng synchronization, pwedeng mawala yung phone sa kumbaga parang kung yan, nagkukwentuhan tayo, pinag-uusapan natin ganito, akala mo ganito. So, hindi kayo magkakaintindihan. So, it's the same way. Kaya, pag makita niyo sa mga term, you have the synchronization because you need to be synchronized to the network. Oh, ito, may question. Is it not possible to invent omnidirectional antenna instead of to cover more subscribers? Paano ko sagutin to? This is possible, but mostly this is used for indoor. Okay, you have the indoor antennas. If you go to sa mga malls, makikita niyo sa taas ng mga malls, meron dong makikita kayo na parang spaceship. Yun, mga omnidirectional antennas yun. But this poses a problem. Maraming makikreate na problema if you use it outdoors because you cannot control it. Pag meron kang, if you have the omnidirectional antennas propagating sa outdoor. So it's confined in the indoor to implement. So that's why it's better to have omnidirectional antenna. But you still have panel antennas indoor to make it directional. Basically, we're not using this because you cannot steer the directionality of the propagation. Okay. Yan. Okay. Thank you, sir. Also, the gain. So usually when you're speaking of antennas, you're talking about the gain. And later makikita natin yan. Later we will discuss why is it important later sa MIMO. Okay? So you have the receive signal power, you have the RSRQ, the quality. So even if you are full bar, for example, here, and then you still have problems with interference, or may mga either we have external interference or internal interference, you're suffering with the quality. So you really need to measure those. And in the decision making of the radio access network, you have to have these three and other things, but yeah, basically these are major measurement quantities that you have to look into. Okay? Question po? Question? Another? Thank you. What about VSWR, RTWP? What do you mean po? Okay. So I think maybe because we're talking about the RAN, VSWR, RTW is, okay, let's go to the VSWR. You know the standing wave ratio. If you go to RCOMS 101, so if medyo madumi yung, kasi pag balik tayo dito, previously, okay, may feeder, ito pala, nalimutan ko pa lang ibanggitin kanina. I forgot to mention that, of course, these you have the feeder cables here going, you have to send the signal, electrical signal by cables, right? So we have our cables, or you have the fiber optics. Okay, you have here the fiber optics, and then you have the feeder cables coming here. So if you have the if madumi yan, your standing wave is more than one, then you have problems with transmitting the electrical signal. So if isa rin yan sa mini-measure, usually pag may pangit, kunyari sa quality, malakas ang signal mo pero pangit ang quality, unang tinitingnan, the first thing that you look into is the possibility of the VSWR if there's is one in the network. Hardware muna before we look into external interference. Okay. So ito po, drive test is the way we do the measurement. Okay. We need to have a real world view of what's happening in the radio access network. And one way is through active measurement, or what we call drive test. Ito po na mga nasa telco industry. Okay, and one way is to have this software. So you have TEMS, you have NEMO, you have this Pilot Pioneer. I'm not sure. Pilot Pioneer, I think this is Dingli, and if I'm not mistaken. But anyway, basically pare-pareho lang ginagawa niyan, because on the downlink, on the uplink, you're sending measurements, you're sending messages. Sabi ko nga kanina, we are synchronizing with the network, and one way to do it is to communication. So downlink, you have the uplink. So the UE will tell, I have this level, and then the radio access network will do decisions, and then it will give you direction what to do next. Are you going to have handover? Going to have reselection, or you have to downgrade or to upgrade your CQI. So dito makikita nyo, sa mga hindi familiar, for some layman, you have the speed test. So dito is simply telling you what's your ping, what's your downlink, and your uplink throughput in throughput based from the Mbps. Okay, so megabits per second. But if you delve deeper, and you have to have deeper understanding of what's happening, or you're optimizing the network. So for those people who are doing RF optimization, you have to know how to read this one. For basically this one, ano ba to? This drive test sample is, I think this is NSA. I mean, in the video, I think it's also smart communication. So you have the NSA. So you have two legs. You have the LTE and the NR. You are anchored on the LTE. So you're basically seeing, let's have 10. Let's name 10. 10. So ito RSRP. Okay, in dBm. So you have 67. So makita niyo naka-green siya. So 67 is a good indicator that you have a good coverage. And then you have the SINR here, 12, okay, or 13, medyo malabo. Okay. And then you have the PCI. Okay. And then ito 150, okay. So yung may nagtanong kanina regarding the frequency, so you're seeing the downlink frequency here, AARCN, I'm not sure if everyone is familiar, but basically you have the 150. Ano ba ang 150? 150 is, I think it's 120-100. Tama? Okay, it's a 2100. When you say 2100, so you have like 2100 megahertz. But in the 3GPP, they are symbolized, or they are, parang ito yung proxy number, okay? To indicate that 150 is 2100. Meron niyang, minsan makikita mo diyan, saan ba ito? May RFCN din eh. Sa NR naman is called ARCN. Sa mga 2G, ARCN, absolute radio frequency something number, okay? Ito naman is ARCN. I forgot what the term, what you call this, the E, but it means the LTE, okay? So 150 is 2100. I think 1350 or 1350 is 1800. Depende on the operator kung ano yung nabili nila or na-auction nila na spectrum. Okay? So kita din natin dito using SDD. Yeah, maraming information. Okay. Makita niyo rin yung throughput dito. Okay? The throughput for LTE leg would be, nasa ba? So, hindi ata naka-indicate dito. Kasi ano na to? Ito pala. Nandito. Okay. So nakikita mo, you'll see here the MAC layer, physical layer, RLC, PDCP. And then you have the NR leg, you have PDCP, RLC, MAC, physical layer. So this is an NSA. Siguro yung the site is that serving is an NSA site. So ito yung NR. NR is new radio. Kung sa hindi pa familiar, this is basically the 5G. Okay, yeah, ito pala. Ito yung band. 78. 78. Ano ba ang 78? NR 78. I'm not familiar. Okay. So, yeah, may corresponding to. I think this is 3500 kung may makakasagot po sa ano. So, basta alam ko, sure to, 150 is 21, LTE 21, and this is NR 78. And you have, ito, okay, yun. Hindi ko pa hinahanap. The SSRP. Yung pinakita ko, the SRP I showed before is for the 5G. SRP, it's the same term as RSRP, but you have the SS here, and you have the CSI here. So, yan. Okay, it's so good. Meron tayong maganda. 68, like 68. So, dun po sa non-telco people, the more negative you are, mas pangit. Kasi if you look at the X and Y axis, if you're neg 68, if you go farther from 0, pumapangit ka. Okay? So, yan yun. So, neg 100 is not good indicator. Actually, for LTE still okay. Sabi natin mga neg 140 ganyan. O neg 120, that's a good magre-red na yon. It will go red here sa measurement. Okay? But neg 68 yan. Either nasa tapat ka na mismo ng site or you're in the main lobe. If you go back to the antenna theory kanina, if you're in the main lobe, you're basically getting this. And your SINR is good also. Okay? Question is, paano po kanyari po you have good RSRP and then you're bad SINR, then there's something wrong. Okay? Either there's interference or there's hardware problem. Yan. Medyo you have to go deeper and have root cause analysis what's happening. Ano ba makita natin dito? Okay, medyo advanced na po kasi ito. You have the P-cell, S-cell. Basically, you're using the LTE is using carrier aggregation. It's a different technology, different session. But anyway, in LTE, you're basically like aggregating carriers. Yeah, the question of one engineer kanina is that basically different frequencies are using different layer. So basically here you have the P, which is primary cell. You're using 2100, and then you have the secondary cell. So inad mo lang yan, you aggregated it. So para why you're aggregating it is to have more capacity, and you have higher throughput. So 2cc to. I think this is 2cc. Kasi isa lang yung SL eh. So sa mga telco guys natin, you know, right? You have this is 2cc. And the secondary layer or secondary cell is 1775. What's 1775? I think it's L18 if I'm not mistaken. So they're using the same PCI kasi it's the same site. Okay. So Mode 3, RSRP, they're good. The reason why it was added as secondary cell is because maganda rin yung signal niya. Because if you have a poor coverage for that cell, you'll not be added as a secondary cell. RSRQ, good, yeah, SINR. Okay, yeah. So to give you additional information, if you have carrier aggregation, mas mataas yung throughput mo, and then you have NSA. And mostly in NSA, you have the ENDC implementation, and meaning you have the master and you have the slave here, or ano ba tawag to? She would be you have the master and then you have the slave. Okay, so you have naka-anchor ka, you're anchored with the LTE, so you have, and then you're being helped by the NR. So you're basically increasing your throughput. Ayan, ito pala, nasa speed test natin is that it's getting 518 Mbps because this is NSA. And then makita, ito yung mga messages. NR cell release, event B1. So medyo advanced na po yan. So any question po, let's go to the Q&A. Thank you. Also, Omni also used but unlimited schedule to shorter reach. Yeah, yan po. Shorter reach because of the gain. Yan. Mamaya ano natin. We'll be discussing. Hi sir, in terms of speed or throughput is possible for the down. Totoong buhay po ay hindi. In terms of speed or throughput, is it possible for the DLUL to be symmetric? Even before 19 kopong-kopong or 2G, always uplink limited because you have the base station, parang you have a Gulayat, and then you have the base station would be the Gulayat, and the UEs or the phone would be the, sino yung kilaban niya? Si Solomon. Basta yung king sa vibe. Nalimutan ko. So David and Goliath. So I mean, you can transmit, and you have the hardware to have farther distances for the base station, but you have the phone, and you are limited by the power of the phone. So you'll always be uplink limited, and it will not always be symmetric. So, kahit po anong gawin natin. And also, from my previous projects, always uplink is always the problem. Okay, so you have feature enhancing. You have features that could enhance this for different traditional RAN vendors, but you can do as far as by this feature. But hindi mo talaga, you cannot match the downlink talaga. Okay. Also, Ogu, the L goes from Genomic phone. Yeah, that's what I'm saying. So you have 40 watts. Okay. So imagine if you have 40 watts in your pocket, wala na po tayo mga anak pag ganun. The UL is handled from phone to GNB. Power is handled by phone. Yeah. Okay. Thank you po for that. Okay. Chat. Ano po muna sa chat? Yeah. David, thank you po. B frequency, SCC frequency. How do we have care aggregation and NSA split? Ano po to? Do we have carrier aggregation NSA? Yes po, but I'm not familiar because with my previous projects, they're not yet implementing because mostly they're using only one FR or one frequency yet. So, but it's possible that you have features to implement. So if you have FR1, FR2 implementing, so basically you can aggregate them. Hi sir, the display you're showing is test under ideal condition. I would say yes. I think it's in near the site. Wala po kasing mapa. Usually with the drive test measurement, you have the map. So I cannot really say. But based from the signal strength and the quality, you will be in the ideal condition. So if I kung nakuha ko lang yung mapa nito, maybe either it's in the major lobe of the site. How about for the worst? Well, pag worst, you'll see red here. So worst condition will be away from the site or from the cell edge, null point. In this case, for example, in real life, if in Metro Manila, you go to Antipolo or you go to the provinces, dadaan ka ng mga bundok, you go to the construction, buildings, yan, you will have the real life or the real life implementation that you'll have some fading, and then you'll see some degradation now with the signal, degradation with the quality. But yes, this is the idea. I would like to think this is the ideal condition. Next. Okay. Animated lang pala to. Ayan. So it's moving, or I can't really say if it's moving. But kahit nakatigil ka, stationary, gumagalaw talaga sila. So I think some telco guys here had done drive testing. It's fun until 2 oras ka nag-drive test, hindi na siya masaya. So basically, sa mga hindi may alam, drive testing is like nasa sasakyan ka, nakaupo, you have your laptop. So I would recommend wag niyo ilagay sa laptop, masama yan, lalo pag lalaki. So yeah, may kanya-kanya mga pektos yan. May mga naglalagay ng basta may kanya-kanya yan eh. Pag sanay ka ng drive tester, you know what to do. So basically, you're driving around the city or an area, and then you're getting the measurement. Okay? So basically, laging gumagalaw yan. Unless you're testing for a feature or something na kailangan mo lang ng ideal condition, you have to be under the site. So yeah. In a radio access network, if you're doing optimization, you have a lot of measurements, diba? Downlink, uplink, and then you're doing decisions. And not you, the radio access network. Okay. You have to make the radio access network needs to have decisions, and since machine yan, ang only way ang love language nila is threshold. So you have the threshold in any G. If you go to 2G, you go to 3G, you go to 4G, 5G, and I think in the succeeding Gs, you'll always have threshold, you always have hysteresis, and always time to trigger. Hindi siya impulsive, kagaya nating mga tao. The radio access network is very intuitive. Pinag-iisipan niya bago siya gumawa ng decision sa buhay. So I think it's a lesson also for us. Gayahin natin be a radio access network. We should have threshold, we should have hysteresis, and have time to trigger. Okay? So bakit? Okay, so a generic example to explain how the event threshold, hysteresis, and time to trigger control event triggering. Ito yung sinasabi ko. Okay? So it's bago niya gawin to, bago siya bumitaw, pinag-iisipan. Okay? Yan, lesson sa buhay. Event B1. So maraming events. Okay? Let's focus on the B1 because it's inter-RAT or inter-radio access technology. This is the event where you have where the radio access network decides to go to a different radio access technology. So what is a radio access technology? Is either you go to the GSM, you go to the WCDMA or the UMTS, the 3G, or you go to the 4G. Okay, kung nasa 4G ka, you go to the 3G. 3G, you go to the 4G. Okay. In the Philippines, I think we have like for the voice, for the data, we're going from 4G downward to the 3G. Okay, and then from pag nasa 3G ka na, it's not allowing you to go back unless the session stops and you reselect to the LTE. Okay. So event B1 is IRAT neighbor becomes better than threshold. So which could be either, yeah, okay. That's why we discuss about the SRP and the SRQ. So either is RSRP and RSRQ. So if we go to this graph, let's have the pointer. Okay, you have the x-axis and the y-axis. This is time domain. So you have the time here, and then you have the measurements here. So you have the RSRP or RSRQ. So the triggering is either RSRP or RSRQ. If you're in the telecom industry, you'll be familiar with this one. So the implementation, you have the features. So either you enable it either RSRP based or RSRQ based. So sometimes they're both, sometimes they should be either RSP or RSRQ. So for sake of simplicity, let's see, ito yung signal natin sa totoong buhay. Ganyan talaga siya. Because of the fading, multipath fading, mag-iiba-iba talaga yung levels. So, if you remember a while ago, you have cell A, cell B, you have to decide when to hand over, okay? And this is one way of the radio access network to decide. So you have in the threshold, you have the leaving level, okay, or the entering level, okay, and then you have the hysteresis. Kasi nga, remember, signal is not linear. So medyo fickle-minded siya. Paiba-iba ng either mataas siya, biglang babaksak. So this is very evident. For example, if you're in the CBD, lumiko ka ng unless but you will not be experiencing it now because syempre 22 decades of planning and optimization and may mga small cells and all, medyo okay na tayo sa CBDs. But for example, if you're in the provinces, liliko ka kunyari sa isang, you go to around a mountain and then nasa kabila yung isang site, malamang babaksak yung signal mo. And then biglang makakaroon ka naman ng line of sight, biglang gaganda na naman. So hindi ka guaranteed talaga ng level. So that's why you have the hysteresis. Right? So hindi porke sinabi niya, sabi ng phone, I'm already neg 140, ayoko na sa life. So, i-hand over ka na ba niya agad? Not necessarily. You still have the hysteresis. Okay? You're setting the threshold. You're telling the radio access network, I'll be hand overing at this level or in this quality. But not necessarily when you attain that level, you decide again. You decide immediately. It still needs to have hysteresis. And since this is time domain, it's a function of time. I mean, time heals. Joke lang. In time, kailangan mong bigyan ng sarili mo ng time. Okay? Same for the UEs, for the phone. You have to give it time to think about it, right? And you still have the hysteresis. So you're saying the radio access network to hand over at this level, but not necessarily at that level. Pag, for example, I want you to hand over like in neg 95, but you put a hysteresis like plus minus. Okay, if you reach that, kasi this threshold is the one you define in the network. Ito yung parameter. Okay, to help you decide. And if you're in the open RAN, ito yung inilalagay mo sa non-real time. Okay? So ito yung you're dictating to the network that in this threshold, you make the decisions. But you still have the hysteresis. So if you reach the hysteresis value, the threshold plus hysteresis, and then you have this leaving level. So dito ka palang magsasabi na, okay, let's start to measure and then wait. Since this is a function of time, let's wait. You reach the entering level. And then since it's a function of time, you have the time to trigger. So you have the threshold, you have the hysteresis, and then you have time. So in this period, ganito ka ba kaganda? Are you good at this within this span of time? If you reach that, then good, will trigger. If not, then wala. We do not do a decision. Okay? Time to trigger, measurement sense, okay, yeah, it's a sense, yeah. Subsequent report sent every report interval up total of report amount time. So you're sending reports. That's why you're waiting. Okay. Event left, event entered. So, yeah. In this case, in this example, nagkaroon ka ng level kasi in this part, before the time to trigger, you went down the entering level. So, okay, cool, chill, 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 hindi muna ako papasok sa'yo. And then you entered that threshold hysteresis, and then you maintain that level. And then you reach the time to trigger. Okay, at this time, ganito pa rin ang level ko. So, the event is entered. Okay? Event is entered when signal is above entering level, continually for time to trigger. First report is sent. Okay? You're sending report. Okay? You're monitoring. Pero this is the real life signal. Okay? So, tuloy ang buhay natin dito. Nakapasok ka na. And then you're monitoring na. Okay? And then monitoring what? The threshold. And plus the hysteresis. And then you still have the time to trigger for the leaving. Okay? Not necessarily bumaba ka dito is you decide. You need to have time to see, or the window, average window. So after the time to trigger is set, okay, mababa ako, I have a low signal, then you leave. So this is not necessarily a one event. Other events have this, but basic idea is that you have the threshold, you have the hysteresis, and then you have time to trigger. Laging may ganyan. Any vendor. Okay? You're doing optimization, and you have to decide that the network should hand over easily. So sometimes you put the hysteresis to 0 para parang bilisan mo, mag-decide ka na. You have to decide now, right? So you put the 0. But if you want to make it less attractive, you increase the hysteresis. Yeah, these are all the nuances of radio access network optimization. But yeah, you can set it. So depends on your what you want to do. And in the traditional radio access network, this is decided first by the people in behind the radio access network group. So ikaw ang magde-decide. You put the hysteresis, you have put the threshold. But currently you have the self-optimizing network, the SON, that taking care of this. But sometimes there are some problems in real life. In paper, it's good, but for the implementation, sometimes mas nakakalurky pa, nagkakagulo-gulo pag kunyari if you use the self-optimizing network. And I think for the Open RAN, and you have the SMO, you have the RIC, and then you're introducing AI and ML, I think magiging mas intuitive na. You don't have to, like, for example, in some events, like for example, ng election, you have rallies, and in rallies, there are certain areas that bigla na lang there will be a lot of people using the network. So you have to adjust the network. You have to adjust the thresholds, you have to adjust the hysteresis just to cater for those. So if you have AI and ML, you don't need to revisit it. You just train the network na if the network detects this massive event, siya na mag-adjust para sa'yo. Okay? But on the basic level, there is still using threshold, hysteresis, and time to trigger. Any question po before we go to okay. Hysteresis is used to trigger handover the conserving site, measuring this from the UE point of view. If it's trigger, which neighboring site will user be handed over? Paano ko ba if I'm understanding it correctly, it depends po on the implementation. Depende po sa vendor. But I think if we look at it, this is based from the UE point of view. and it's both measuring, okay, both measuring the serving, and also it needs to measure the neighboring cell. But first, you have, when you're deciding, uh, uh, you have to look also for both levels. That's why in this event B1, IRAT neighbor becomes better than threshold, is because it's monitoring also the neighbor. So if it sees that the neighbor is better than the threshold plus the hysteresis, if the hysteresis is at 0, then you have the threshold. So when you say IRAT neighbor becomes better than threshold, that's actually better than threshold plus the hysteresis. So that's why when I say make it more attractive or make it more less attractive, you're putting hysteresis. I mean, you put the threshold like, for example, I'm doing Hanover or reselection on neg 110. It's not actually neg 110. You put hysteresis not like, okay, neg 110, let's put a 3 dB hysteresis, so that would actually be plus minus. Okay, you can put plus minus. Minus meaning you make it it depends on its implementation, because there's a level na either above or below. So for example, in this example, you have the threshold above. So if it's above the RSRP, so you enter and then you leave. So depende din po sa mga events. But the idea is that the hysteresis is giving you what do you call this? It's not a guard band. I mean, it's a gap. It's a buffer for you before you do the decisions. So, nasagot po ba yung sa inyo? If it's trigger, which neighboring site will be used or be handed over? So, depende po. If it's monitoring the neighbor, so whichever has the highest level that it measured based from the threshold, yun po yung magiging ano niya, target nung siya mag-handover. Always used for congested to non-congested sector. Critical util low still offloading. Thank you po, offset. Wishing a level handover takes place. It depends po sa threshold. Okay? May mga if depende po sa set nyo. For example, if I put it in neg 120, so if it reach neg 120, then be it. Plus hysteresis, So dun po siya mag-decide. Offloading, load balancing. So every neighbor site, we will po discuss mamaya in traffic steering. So every neighbor site on the list is being measured. Hindi po, actually, physical, in real life, we cannot do that. We are limited by the measurement report. So kung ilan lang po, I think, I'm not sure ilang measurement, but if I remember in 3G, you have the monitored set site, so you have the detected sets. You can do as much this number of neighbor being measured, and also depending on what neighbor you define. May ganyan pa po. Okay? In the network, you also define your neighbors. So hindi po lahat min-measure. Depende din po sa dinefine nyo ng neighbor. Is the measurement depends also in the distance on the neighbor site. Yes po. Kung gaano po siya kalayo is gano'n din po. It affects how you receive the signal. If malayo na po yung neighbor, may mga ganyan pong problema sa optimization. Sometimes you define a neighbor that is more than 1 kilometer away, and that would be a problem. Okay, we all now have actually we have intuitive network na with the traditional access radio access network. We have the automatic neighbor relation. We have the ANR, what you call the ANR. So it adds depending on what it measures. So, but before, for example, for the UMTS, for the 2G, you have to define it manually. So, if your neighbor is beyond 1 kilometer at dinefine mo pa rin ang neighbor, pipilitin niya na hanapin yun. Okay? Because it's defined. So, if it sees that frequency, if it sees that BCCH in 2G or scrambling code for 3G or for PCI for LTE, pag nakita niya yun, na-decode niya yun, ma-measure niya. Okay? So that's why in optimization, you have to optimize it. So you don't define cells beyond 1 kilometer. maybe, or 500 meters depending on the clutter. Okay. So you remember the signal kanina po, when you propagate, it's susceptible for fading. The farther it is, the more fading. Does the UE knows who are the neighbors? Yes, yes, opo. Because you define it in the network, you define the neighbors, you then syempre imamalitas niya yan kay UE. Oy, ito yung mga neighbors mo ha. Don't forget. So the UE knows who are the neighbors better that we're using. Okay, so before we go to the use cases, review ulit tayo of the ORAN Alliance. Okay, this is an initiative or interaction between operators, but I think this is mostly European operators with addition of China and Japan. So the ORAN Alliance, which was formed in batang-bata pa, February 2018, with the goal of promoting open and intelligent RAN, is a second organization driving the Open RAN movement. Second organization, why? Because I think it's the TIP, or the Telecom Infra Project. But Telecom Infra Project is an organization or a movement of operators, vendors that are tackling the entirety of the telecom industry. But the ORAN Alliance is specifically for the Open RAN. Kaya nga siya tinawag na ORAN Alliance. And the promotion of open, okay, I'll again reiterate here the open and intelligent. The intelligent RAN is actually the traditional RAN is already intelligent because it's making decisions, as we discussed a while ago, with the thresholds and the austerity, time to trigger, and all these decisions is already intelligent. Intuitive, maybe yes, but not that as expected, because I think for the telecom people here, nangangarag pa rin tayo, di ba? Pag may problema, nangangarag pa rin tayo. If there are massive events, nangangarag pa rin tayo. I remember during the last year elections, mga walang tulog ang tao because we're monitoring the event and we have to deploy how or meow or depende kung nasaan kang operator, but it's basically cellular base station on wheels, cell site on wheels. Okay. If you go to a concert, if you go to an event, massive event, they're deploying for additional capacity and additional coverage. And hindi siya madali. It's very, especially if, for example, like from the last year's election, they will declare this rally 5 days before. So we have like 5 days window to prepare. And iba pa yung mga sa field, if there are O&M guys here or field guys here who's deploying the hardware, mas ngarag yung mga yan because there are meron pang kuryente, merong ganito, merong civil. But for the radio access network people, ngarag din because they're pressured because they have to set the thresholds, they have to set these parameters. And then even if you have the self-optimizing network, for those who are not familiar, that's why I am telling you that the traditional RAN is already intelligent because you have the self-optimizing network. And different vendors have the different implementation, not that intuitive, but at least it's different from 10 years ago, okay? Because you can set massive event handling by setting these settings for this kind of event. The network is agnostic with the human events. It doesn't know if sa pula o sa pink, hindi joke lang. Hindi niya alam na if this massive event is this big or if this concert is this big, or it will only know depending on the measurements. Okay, so it will only know if it detects that if you have a massive event, if it detects this amount of UEs, it will detect this massive this decision or these parameters. Okay, so actually it's actually intelligent because like GSM, like 2006, 2007, those days, medyo if you want to have this, you set this one. So pag nagbago na naman, if the condition differs or changes, you have to set it manually again. And you're only reacting, okay? you're only reacting to it after the thought, after the fact. Okay. For example, you're monitoring the KPI. Pumangit ang KPI because the traffic increased. So ikaw as a radio access network in specialist or practitioner, you have to change the parameter to adapt to the new condition, right? That was years ago, decades ago. But now you have the self-optimizing network wherein kahit tulog ka, it will decide for you. Pagising mo, okay, medyo it has a delay, yes, but at least you don't have to look for the KPIs, okay, the indicators na pumangit siya, because that will take like hours or maybe days before you find out. So, but with the self-optimizing or the self-optimizing network, it helps you to be more intelligent or more proactive. So, if it sees that the UEs are increasing, so it will decide to change the parameter set to this. Okay, so. But I think for these operators in the O-RAN Alliance, maybe the intelligence is hindi pa rin sila, they're not satisfied. Okay? And also, one thing is the open. Okay? Openness. So, the traditional RAN is not open. Okay? If an operator buys from this vendor A, it will be beholden for that vendor A for this number of years. Okay? So all the features, all the parameters, all the implementation are based from the features from that vendor A. So magbabago it will only change if you swap to a vendor B or a vendor C. Okay? So napag-usapan siguro with these operators that it should be open. But open because there are a lot of possibilities when you have a technology that is open. One example is Android. Okay? Android killed the previous technology because it's a network effect. I mean, being an open is that you invite different kinds of people, different kinds of expertise to join in. And dun nga, makita mo that everyone develops everyone. Everyone develops everything because it's open source. Okay? So if technology is open, there's a lot of collaboration and a lot of innovation. So open and intelligent, yan yung gusto nila. It was created by the merging of two organizations. So may existing na before 2018. You have the C-RAN or the Centralized RAN Alliance of China Mobile and other mainly Chinese vendor. Okay. If I can remember it right, wala pang virtualization. I think there's certain for telecom professionals, malalaman nyo kung anong kung anong vendor to. But I will not share because lahat naman tayo telecom dito. So there's this one vendor na looking into centralizing the RAN already. I think meron ako nakitang video before that you have this vendor can deploy immediately by getting that just one hardware plug and play, and that's it, because everything is centralized. They don't have to set up the whole pack. So there is a C-RAN alliance. So there is an initiative to centralize the RAN already, and it is driven by China Mobile and other Chinese vendors. So you will know what vendor that is. And then you have the NTT Docomo and other mainly American vendors. You have the XRAN. So XRAN meaning X meaning you have visualized, because you have visualized, you have T-RAN, you have VRAN and all those RAN. So you're looking into innovating the RAN. So, but there's no discussion of openness yet. You're just telling us that maybe we should centralize the RAN. Okay? Kasi before, in the 2G, RAN is its own world. I mean, one base station, andyan lang yan. One base station, you have one controller, like a BSC. Or in 3G, you have the RNC. And then you have the RAN. It's not centralized. They have their own. Okay? So there are initiative before na maybe we could centralize, and then for the American vendors, maybe we could virtualize so that we lower the cost. So there are this organization before 2018, and it seems that usap-usap tayo ng hiwa-hiwalay, but we're going into one path. That's why nag-merge sila. And okay, let's just make one alliance to have one discussion, and that's it. Because without this alliance, we will have that technical specifications. It's like the TGPP. It's also an alliance before. There are different vendors, different operators, different telecom stakeholders who banded together and sit down and discuss specifications. And same happening here, the Oral Alliance. And the founding operators, of course, are American and Chinese companies like AT&T. You have China Mobile, Deutsche Telekom, NTT Docomo, and Orange. Orange, I think it's French company. Okay, so yeah. So you have European, American, Chinese. So ito yung mga members of the G8, G7, lahat ng mga mayamang countries. So the Oral Alliance is a group of telecom companies that aim to improve the performance and openness, of their networks. They call for more intelligence in the network through information collection for the visualized network elements, artificial intelligence, AI, and machine learning, ML, that can be applied to this collection. So visualized network elements, yes, this can be part of the traditional RAN. There are some RAN that are already visualized in the cloud, but the elements missing are openness and this AI and ML. So there are a lot of telecom guys here. So this is a big thing for us, okay? Or because this is RAN. So RAN optimizer, integrators, type testers, even the civil works. For sure, we're here. For sure, we're stakeholders here. But with ORAN, we're opening our doors for our brothers in the IT industry. The IT guys now can be a stakeholder in the telecom industry. Okay, and vice versa. Okay, the telecom guys can now be into IT. We can learn AI and machine learning. So if you're if you're keen on studying AI as an additional knowledge, magagamit na natin even if you're telco, because we have the X apps. If you remember, you have the X apps, the R apps in the RIC. So it's already programmable, and maybe for those guys, maybe 20 years in the telecom industry, pagod na, you can change career, but still, we're still in the telco, right? You can be a programmer for the RIC, and it will be easier for us, right? It will be easier for telco guys to transition to IT because we'll just need to learn the programming language, but we know how to make the flowchart because we know how RAN works, right? We know the hysteresis. We know how hysteresis works. We know how thresholds work. We know how the beamforming works. So we just need to learn the programming language to translate it. But medyo mahirap din mag-code. So papasok na yung mga IT guys to teach us how to code. Or maybe they're the one who's coding. We're just giving them instructions. So IT professionals can go into IT as project managers, or maybe not managers because you have to be into the IT. Maybe project consultants to give consultation to the programmers how to do it because we know how RAN works. So the dynamic is changing. The paradigm is changing with ORAN because we're not confined into the RAN. We're also into AI and machine language, and this will be exciting for some, right? So yeah. Okay, so in the ORAN Alliance, you have the ORAN technical working groups. You remember you have the blocks a while ago. these are the targets, these are your goals. But the people should have working groups where they can discuss policies, the configuration, the design. How do we implement this? And you cannot discuss in a plenary. So, for example, if you're in a plenary, you usually go to the breakout rooms because you cannot discuss this topic in a plenary. You have to discuss it in a smaller groups. And this is what's happening here. So the ORAN technical working groups are divided, I think, I remember in the pretest you have the W1. So the working group 1 is the one looking into the use case, and I think that's I think what you need now. Okay, so to know. So if you want to know more about the working groups, you go to the ORAN site and you will see there the other working groups, because there are other working groups. There are core also. There are transmissions and all these working groups. Now, depending on the expertise, because for example, for run guys like for me, I can't go to the transmission group and says my expertise because I don't know anything about transmission. So I leave it to the transmission guide. So the run part, or this one, the use cases, those that are into the radio access network. So if you go here, basically we're like we're looking into the architecture, okay, and the working groups is based from that architecture. So for example, in the SMO, you have here the design, the inventory, the policy, the configuration, and then you have the run intelligent controller. Okay, non-RT, iba pa yung non-RT, iba pa yung sa near RT. And then you have those that are talking about the open front hall. Okay, there is a working group here, discussing that. And then you have the CU, the centralized unit, and then you have the distributed unit. So we'll not go deeper into this one, but what I'm telling you is that there are different working groups that are discussing depending on their expertise. So we are all ECE, yeah. It's no denying we are all ECEs. And sabi nga nila, if maybe a professor is telling you before that we are like jack of all trades. So we graduate as an ECE, but parang hindi pa natin alam ang gusto natin sa buhay. So depende na lang siguro kung sino nag-hire sa atin sa simula. Because before, I was hired as a semiconductor engineer, and I thought tatanda na ako sa semicon industry, but here I am in the telecom industry. So, but it's not limiting us for different industry. But of course, hindi naman tayo pwedeng talagang, as we progress on, or euphemistically, pagtanda natin, tumatanda tayo, we cannot really, we have to focus on something, right? So for the telecom guys here, you're now focusing on the telecom. For the IT guys, you're now focusing on the IT. But here is the ORAN that's giving us an opportunity to merge and to collaborate. So yeah. Symbian. Yes, sir. Nabutan nyo pa. Diba? Namatay na yung Symbian. Kasi nga, Symbian is Nokia. So, closed yun. Hindi siya open. Kaya ayun, nangyari. So yeah, you know, Nokia, these traditional RAN vendors are actually developing their open RAN. At the same time, still doing their traditional RAN. They have learned their lesson na if ever the ORAN is widely accepted or widely adopted, then hindi siya nakapag-iwanan. Okay? They have learned the lesson. FEHF. Tama. Event handling. FIBA, yes, of course. Saan po ba to? Sa Philippine Arena. Excellent insight. Okay, yan po. I'm a classical ECE, but deep diving into ML deployment when a large language model. Yes po. You'll be a lot of help po when we do programming and in the X app or R app. You can apply that one. Okay, so this one, streamline lang natin. Para medyo ano kanina eh. So you have the service management orchestration framework, and here you can see the non-real-time RAN intelligent controller, and then you have the near real-time RAN intelligent controller. You have the XApp here. The RApps are in the non-real-time. So you have the XApp here, and then you open front hole. May nag-uusap-usap din for collective interfaces like the E2, O2, O1, and then you have the distributed unit, you have the radio unit, you have the centralized unit, and then you have the O-cloud. Of course, people should, experts should discuss also on the O-cloud. How do we migrate into the cloud? Okay, so let's leave it to the working groups, our heroes for O-RAN, and give us their final specifications to guide us. I think there's a document already, like what I said before. So if you want a light reading, you can go to there and to their site and check it for yourself. Okay, so let's go back. Benefits of O-RAN architecture. O-RAN is capable of reducing a network capex and OPEX. This is for our operators. You know, lahat naman po these are all money. So the question from operator is, how can we get the profit? Okay, so and O-RAN promises a reduction in the capital expenditures and operational expenditures. So review lang po natin if ever hindi pa po na anong iba. Capital expenditures, ito po yung pag magsisimula. If you have the capital, okay? Capital natin is how do we start the first initial investments that we do, okay? So we cannot start a venture without any capital expenditures. And then the capital expenditure doesn't stop. In different phases of the network, you have to capitalize again. Like for example, the 5G is coming, so the network should be capitalizing on expanding. If there's no money, no expansion. And I think for the telecom guys here, you feel that, okay? You're recommending expansion, but you cannot do anything because you don't have the money. So you have the capex. And then the operational expenditures would be like the operational, the day-to-day. So you have rolled out, so you have a functioning network. So you have the operational like kuryente and the rent, okay? So and then the pasweldo, the sahod ng mga tao. So you have the operational expenditure. So O-RAN promises to reduce all those. So how can it how can it attain that? So capex is because it's just an open RAN, so there's a lot of competition and then a lot of vendors now coming in. So there would be economies of scale. Ay, tama ba yung term ko na yun? If you are a lot of players, you have to lower costs to be competitive. So in the point of view of my MNOs, operators, that would be less cost. Operational expenditures easier to maintain because why? You're already in the cloud, right? So you're maintaining the hardware. Actually, for this, you're like maintaining the RU, and in some cases, the distributed unit and the RU are on the physical side, and then CU up is in the cloud already. Okay, so you have to pay, either you house it in the AWS or maybe house it in the Google Cloud or Microsoft Azure. Okay, Azure. I don't know how to pronounce it, but yeah, you can house it anywhere. Okay. So O-RAN is capable of improving network efficiency and performance. Yeah, this is a promise. Not that the traditional network or the traditional RAN is capable, but since it's programmable, okay, you have AI, ML, you basically have this opportunity to improve the network efficiency and performance. Okay, O-RAN is capable of importing new capability with great agility. Yeah, this is one way of malaking bentahe or a sell point for O-RAN is the agility. It's easier to scale because everything is virtualized. You can just create the VNF or the instance, and they can have rollout faster, okay, or upgrade faster. It's agile. So I think people here are into agile. You know what? Yeah. So okay. So there are phases: phase 1, phase 2 of O-RAN Alliance, and actually these are priorities, but even if you have priorities, you still have phases, right? So, orang key usages phase 1, you can see here the low-cost run white box hardware. White box meaning ito yung mga, these are the bare metal hardware. So, there's still no software. So, these are great opportunities for some companies who offers white box hardware to go into telecom industry. Yeah. So there are people talking how to standardize this or how to set the specifications. And then you have the traffic steering, which will be discussed later. QoE optimization, discussed later. And you'll see the what are impacted blocks in the architecture. So you have the massive MIMO optimization, QoS basis or something. Actually, these things are already being seen on the traditional network, but what is just saying is that since these are priorities, kaya nga siya ginawang priority 0 is because these are already existing in the traditional network. But the promise of overrun is that it will be carried over and better. Okay. Phase 2, you have run sharing, run slice SLA, context-based dynamic handover, flight path, or the UAV or unmanned aerial vehicle, and resource allocation for UAV applications. But for here, we'll be discussing for the phase 2, we'll go, para hindi po tayo maubusan oras, is go to the UAV. And here we discuss traffic steering, QoE, and massive MIMO. QoS-based resource optimization. Okay. So here, just a detail of the use cases, what are their type, okay, impacted interfaces, and the blocks or the entities. Okay. Phase 1, phase 2. Okay. Okay, let's go to one use case, which is traffic steering. For telco professionals here, I think you have an idea what is this traffic steering. Because in any radio access network or in any network, there's always a case of capacity, and the planned capacity or the calculated capacity will not always be enough in the coming years. It can be congested as the network grows. Okay, so we have to have the flexibility to shift traffic. Okay, so that you can address the capacity issues. So ORAN traffic steering is okay. Let's go here so that we can discuss one by one. So the realization, okay, RIC to control the adaptation of diverse scenarios and objectives, non-RT or non-real-time RIC and near real-time RIC controls traffic steering strategies through AI ML learning from data collected by so itong mga interfaces, open frontal, open interfaces from the centralized unit and the distributed unit. So you remember a while ago, you have the measurement reports coming from the UEs. So for those IT guys that are into AI or ML, you know that we need to have a training data, right? So training data in this case would be those coming from the measurement reports because they're sending you the actual measurements or the actual landscape of the area. So is that would be our training data. So being sent via this interfaces, and then it's now being processed in the RAC. So we have the non-real time where you have all those R apps, and then for near real time. Okay, so I think dun sa hindi pa for those that are maybe forgot or maybe were not aware, non-real time, these are all those applications that are greater than 1 second. Okay, and then near real time would be those that are less 1 second. So those that are needing immediate decisions, and then this one is those for the maybe a macro level like landscape. I mean, macro level decisions. Okay, na hindi mo kailangan, or the decisions that are not less than 1 second. Okay? Kaya nga near real time. So challenge. Okay. The challenge would be the typical traffic steering mechanism. Use radio conditions of cell by treating all UEs in the same way, with average values are limited to adjusting the cell selection, handover parameters, and cell priorities. So we're going back to that measurements, right? So yung sinasabi ko nga, we are manually adjusting the thresholds for traffic steering. So parang nagiging reactive. Except for where we have the self-organizing network or self-optimizing network, the SON. But I'm saying that, yeah, I had that experience before working with the SON, and sometimes they are not intuitive. So this is an opportunity for ORAN to have the traffic steering to be more intuitive by employing AI and ML. Okay, so what's the objectives? Customization of UE-centric strategies and proactive optimization by predicting network conditions. You have the prediction. Actually, the SON promises before predictions also, predicting network conditions, but it's falling short of what's expected from it. So I think it's an enhancement. Because we have this, we have the RIC. It's not present in the traditional RAN. So ML to control the adaptation of diverse, because we have the training data now. So for those telco professional and for those not in the telco professional, if you will be given the graph of maybe the traffic for a certain area, it's not the same for all days. For example, in the CBD areas, traffic would be higher Monday to Friday. Why? Because people are coming in from the provinces, from the regions, coming to the CBDs to work. So you have the indoor site there, you have the macro site there. They're concentrating during Monday to Friday, working days. And the traffic goes down for the CBD areas for Saturday and Sunday. Why? Because people are moving out. So with this training data, paulit-ulit lang yun Monday, Friday, taas. Except for holidays, of course. And then, bababa siya on weekends, weekdays, as a training data. So the machine learning will adapt to the current situation. So ML to control the adaptation of diverse scenarios and objectives. Allow operators to specify different objectives of traffic management by optimizing the network, AUA performance, achieving balanced cell load, etc., etc. Yeah, someone I think mentioned a while ago the load balancing. Allow operators to flexibly configure desired optimization policies, utilize right performance criteria, leverage ML to enable intelligent and proactive traffic steering control. So what are the required data? Yeah, what I'm telling you, measurement reports, where you have the level, quality, the CQI of serving and neighbor cells. So, yep, someone asked a while ago, yep, we're measuring the neighbor cells also, serving and neighbor. Cell quality thresholds, measurement gaps, what else? Connection and mobility, indication of successful and failed. Yeah, we have to know that the UE always feedback the network. If it's failed, you have a failure, failed, what do you call this? Failed transaction, or it has a successful transaction, because it needs to know if it needs to measure more or do something more. Okay. Cell load stats, active users, connections, scheduled active users per TTI, PRB utilization, etc., etc. So these are all reported. Okay. Per UE performance stats. Okay. So you have the PDCP throughput, you have the latency, etc., etc. Okay. So Open RAN, ORAN traffic steering use case, node responsibilities. So if we go back to the ORAN architecture, it's basically creating policies depending on the blocks. So for example, in the SMO, here we define the non-real-time RIC. It defines update policies to guide the behavior of the X app in the non-real-time RIC. So optimization objectives to guide carrier band preferences or UE or group. So dito yung for you can define here if what band you're preferring, right? Because in current implementation, we have different bands. You have the higher bands, you have the mid bands, you have the lower bands, and not all bands are created equal. There are bands that are higher, have higher bandwidths. Like for example, L18 or L21 can have 20 megahertz. And later on, in we will discuss channel capacity, and the more bandwidth that you have, the more capacity you'll be getting. Okay, so 20 megahertz, you have 50 megahertz, you have 10 megahertz. Eh bakit iba-iba pa sir yung bandwidth? So it depends on the implementation, and it also depends on the regulating body, how much spectrum it can give you. Okay, or aka ilan ang bibigay sa iyo ng gobyerno. Okay, ilan ang kaya mong bilhin. So you'll have different bandwidths on different bands. So you need to steer traffic on your preferred band. So of course, your preferred band would be the one with the highest bandwidth. Like for example, in some implementation, L18 would have 20 megahertz. So your preference or your priority would be L18 because 20 megahertz will be there. So you define it here. Okay. Perform statistical analysis to provide enrichment info for NR non-real-time RIC to assist the traffic steering function. Example would be RF fingerprint based on UE measurement report like RSRP, RSIQ, CK info serving neighbor cells. So the AI ML, the training data provided to them can come from the measured RSRP and RSIQ CKI. So it will know in that area where is where would be the coverage hole. Okay, because currently in the traditional network, there's a separate processing for that. I mean, we have the crowdsourcing, we have like the MDT or the minimization of drive test. So a while ago, I showed you a drive test, right? That's an active measurement. There's an engineer, there's a car, you're driving around, that's an active measurement. There's also some that rely on the crowdsourcing. I mean, your phone is basically sending information on the level, sending information on the quality, and that information is very crucial in determining the the performance of the network. I mean, in that area, saan ang pangit, saan ang maganda. And knowing where it is not getting the right condition is a way for us to improve and to optimize. Okay, so it's these are basically training data for the AI. Okay, communicates policies and you define the policies of how you want it to adapt. Okay, and it's all here in a non-real-time RIC. So it communicates policies and enrichment or our fingerprints. So that would be the coverage, quality, to non-real-time RIC and measurement configuring parameters to run. So, kumbaga, it's siguro yung principal, the school. So, or the board of trustees, or so the global, or so for some some programmers here, you have the global function and then you have the localized function, right? So, parang ito yung pangkalahatan. This is the general policy that they want. Okay? Priority ko ba sa 1800? Pag low band ba, ganito ang mangyayari, and so forth. So, pag ganitong level ba, anong gagawin ko? If the quality is like this, what would be my decision? Everything here. Okay? And then the policy is the policy is disseminated via the A1 interface. So A1 policy, declarative policy to enable non-real-time RIC to guide the near real-time RIC on steering the behavior run function towards stated objectives. This is the general policy, and then a near real-time RIC is the immediate policy-making body of the network, based on what the UEs are feeding the network, or what's the current conditions now. So A1 additional info used by the non-real-time, the near real-time, sorry, the NRT, the near real-time RIC collected at SMO real-time RSA from non-network data or from other network functions. So you have the near real-time RSA here in the present enforcement policies from non-real-time. So it cannot do its own policies. It's guided by the non-real-time RSA. So uses in-agent info to optimize control function. Example, near real-time RIC can use RF fingerprint to predict interfrequency cell measurements on the interfrequency measurement to speed up the traffic steering, reduce signaling overhead. So example, for example, here the policy is that my priority would be 1800. Okay. Traffic should go first to the 1800 unless it's congested. Okay. But in the near real time, because the mobile is because the mobile is mobile, because mobile is moving, so they are fading and coverage, the signal, RSRP, remember the signal, the quality is ever changing. Diba? I show you the graph a while ago. You have the threshold, you have the hysteresis, you have the time to trigger, but in real life, your signal is comes and go. I mean, up, down, up, down, up, down. And you have to make that crucial decisions because the mind you, time to triggers are in milliseconds. So if you go to the traditional run, if you go to different vendors and you go to the parameters that pertains to time to triggers, they're all basically the units will be in milliseconds. So milliseconds cannot be fathomed by human beings. Because yung 1 second yan, hindi natin alam, di ba? Pag sinuntok ka ng hindi mo alam, wala 1 second yun, pero hindi mo alam. Hindi ka na nakailag unless you're like a super saiyan or something. But near real time for for radio access network is like less than 1 second. So that would be in a millisecond, microsecond domain. So those measurement, i-hand over ba ako, i-reselect ba ako? I need that decision now. And that would be in the near real time. But it is governed by the non-real time. The non-real time RIC, tama. The policy of 1800 first. So your decision to hand over is based from that policy. And it is being carried out or is being disseminated by the A1 interface. Okay? So that's the interaction of this one. So before, the traditional network, wala ito eh. Okay? Actually, wala yung near real time. I mean, I cannot compare it, but in the network, you have the threshold, you define it. So it's there. Okay? The decision will only be, meron din naman siya ng near real time. The decision is very near real time, but it's also based on the policy or the threshold that you have defined, the hysteresis that you have defined, but without the flexibility and the intuitiveness. Okay, because here you have the AI, and via the X app, or here you have the R app, that helps you decide better. Okay, you have the intuition to decide better. So, and then you have the control. Of course, the decisions are made here, but of course the execution are done on the nodes. So you have the control messages. I remember the control plane. So those instructions are sent over to the nodes via the control messages. So it executes. At the same time, you have the measurement, diba? Always the measurement. Every time it does a decision, it measures again to feedback. It's a feedback system. Okay, so it always have to have a feedback. Na this is my level now. This is my quality now. So you have to adapt based from those, and that would happen coming from the UE, going to the node, back to this RAC. Okay, so collects and transmits data with required granularity to SMO over O1 interface. Execute actions. O1 yun dito. From here, yeah. If you go back to the architecture. Let's go. Baka po may question. Okay. Check email. Sorry. How about the antenna? Can it also be adjusted using this ML? Why not? You have this flexibility here. So if if a company, or maybe isang tao lang, iisip niya, the good thing with the oral is that if you are very good in AI and ML and you're good with coding, you can basically create your own company, right? Siyempre, kailangan mo ng BIR and you have to have other government institution. But basically, you can create your own company and it can have that your app and then sell it. Okay, if it's better with other companies, So how about antenna, tilt, electrical tilt? Okay, so yes, you can. If you have the thing is wala. I mean, it's not here, but the specification tells you that you can, right? Because you can. It's programmable. So yung mga IT natin dyan, a lot of opportunities. I mean, I'm seeing a lot of startup companies coming in just for developing X app and R app. Okay. So they don't need to have the hardware. Just have the application. So we'll see. But for now, we don't have that, but it is possible. The antenna adjustment is done with RTS. Thank you po. Okay. So wala na ata. I don't see a network now that without RET because I came from a decade or an age where we don't have the RET. So nakakatamad mag-recommend ng tilting because you have to go to the site and change it yourself. Okay, so that was years ago. But now we have the RET. It's all electrical input now, and electrical input can be a formula, and a formula can be programmed, right? So anything that can be a formula, anything that has formula, anything that has that can be translated into electrical signal can be programmable, and it's all possible here. Okay. So yeah, isang example bakit kaya natin. Okay, any question po? Wala, and then next. Okay, example. Okay, I'm not familiar with this one, but I'm not sure why JSON, or if IT guys, maybe a thumbs up if you know anything about JSON, but it's an accepted template or standard for configuration files. Configuration files are like a while ago I'm telling you about the policies, right? How do you translate it to a policy? So sa tao, if you want to have someone do it and you want to ensure that he does it, you make a contract and you write it. So it's like that. It's like a configuration file. It's a binding contract for the network. Now, if you have written it this way, or the policy this way, it will be set in stone unless you change it. Okay, so this is I think it's in JSON format. Sometimes they use XML, but I think they're now using JSON. So here you can see the properties, UEID, slice ID, QoS ID, cell ID. Okay, so it's telling you the site, and then what else? Slide ID. Yeah, okay. Shall prefer, avoid, forbid. Yeah. So your example, which cell shall be selected. So here you define the cell, and here you define, do you avoid it? Do you prefer? Do you forbid? Shall? Okay. And it's this is higher JSON is I'm not sure how do you call it sa mga programmer dyan, but it's readable. I mean, unlike before C++, medyo dito like Python, parang madali na namang program ngayon because they're using simple languages, okay? Like this one. So yeah, so what I'm showing here is just policies translated into a readable both for the machine and both for human who's sending the policy or setting the policy. Any question po? So yeah, ito it is in the non-real-time way. Pinapadala niya to. Ito ang guiding. This is our guiding principle, is telling the NeoRT. Rick, so whenever it does all decisions less than 1 second, it's guided by this. Okay. So for example, paano? You said you sabihin natin you're crazy enough to avoid all neighbors. So even if you set the thresholds, the what do you call this, thresholds, hysteresis, time to trigger, uh, favorable to a certain cell, but you set it to forbid, you'll not do any handover because you set it, it's your rule, it's your policy, not to hand over to that cell. So yeah. Question po? Okay, any questions sa chat? Yeah, high level languages are the human language. Thank you po. Python as an example, yes. Kasama po ba yung antenna vendors sa ORAN, Rosenberger, Scope Argus? Yeah, I think so because antenna is still there in the open LAN. They're still part of they're still stakeholders in this. So kasama. Lahat na nakita niyo sa telco wala may iwan. Lahat tayo kasama dito. Okay? Connected to radio frequency, on the GP, so open and do not apply for antenna. What I understand is that the antenna vendors still is a stakeholder in the open LAN because it's still a movement. Okay, but in terms of the specifications, you don't have to change anything because antenna is a transducer. Okay, it's not an active element. Unless I think they're developing like in massive MIMO that the antenna and the active element is an active antenna, then yes, it should adhere to the specification. But if it's the classical antenna, I think it's a classical antenna, but you have Rosenberger, you have CommScope, Argus, you have the chain. There are passive elements, so nothing can be done anymore with them. Sasali na lang sila with the movement. But yeah, you have a point there, Sir Carlo. The open LAN, in terms of the specification, we cannot do anything anymore about them. But they're still part of the movement. Yeah. So I think because the question from here is baka daw, tama ba if you're telling me na kasama ko baka yun dito? Yes, of course. All telco would be part of this movement. Okay, more question. Next. Okay, so policies examples, yan. So pinadala na nga cell list, slice ID, QoS7, 67. I think QoS ID for 5G would be, ano ba to? Mission critical video. So yeah, if for those that are not familiar, for telecom, I think you know this, but for non-telecom people, the UE are of course UE should be created equal, but sometimes depending on your subscription, there are policies that needs to be applied to you, maybe for postpaid, for prepaid, and even if you're postpaid, there are also policies depending on the bearer you're using. Bearer meaning what are you doing with your phone? For example, if you're just doing this kind of transaction session, you don't have to get all those bandwidth or all those resources for you to attain. There are also some mission critical functions from the phone or from not only for the phone, for the terminals that needs this kind of QoS. QoS is quality of service. Okay, so mamaya i-discuss pa natin, may QoS pala tayo later. So yeah, so for example, this here QoS ID 67 pertains to like a video critical or a critical mission critical video. So sinasabi lang niya na if this and then the slice, this is a network slicing, and slice 11, I'm not familiar with 11, and the QoS ID 67, you're doing this kind of traffic steering. Ayan, nakalagay pala ito, shall. Cell list, and then you define for this, shall, for this, avoid. So, ito pala, traffic steering per slide. So, you're defining the policy from the non-real time sending it. So, you forbid for this cell list. Okay. So, this is a generic global policy. And then the threshold, the application of how you uh, do decisions less than 1 second would be a near real time. Okay, use case. Yeah, this is just showing you, for example, in 5G, 5QI is like CQI in LTE. 5QI is because of just a term for 5G, just to separate it from LTE. So have voice connection for those 5QI that are one. So this is basically you're grouping the phones, okay? Or no, actually grouping the phones, not because the phone is like this, but because the phone is doing this. Okay, so have voice connection, have MEB. You remember one use cases for 5G would be the enhanced mobile broadband. So voice and broadband is two different things. Voice, yeah, you're just needing this kind of bandwidth. For mobile broadband, of course, you're using this kind of bandwidth, but we're prioritizing voice because this is important. But at the same time, we're applying this bandwidth for broadband. So that's why you're defining this per 5QI. And these are part of that policy. Okay. So for UE, based from this policy, you're steering where it goes. Okay. So because, for example, in GNO would be 1 or A, you have low band, you have narrow band, and you have your low latency. And then for here, you have wide band, you have high bands, and you have high latency. So depending on what you define here, depending on the policy, it will steer on that kind of cell depending on the policy that we've created. So understands requirements of pricing of services. So decides voice and CP connection on low band. Okay, that's why. And then NBB connection preferred on higher band. Why higher band? I remember higher bands usually has the higher bandwidth. Okay, so it's covered by small cell C. D cell, and then D would be for the secondary cells. Then you avoid the low bands. Cell A only for coverage. Yeah. So usually kasi the low band is the one. Low band usually, even from the 2G era, low band usually is the net. Okay. Because low bands, communications 101, lower frequency, right? Lower frequency, you go farther. Okay. Higher frequency, lumiliit, nagsishrink. Okay. So you use the low band. Yeah, that's why because if you go to the electromagnetic spectrum, just below the visible light, the infrared. So you'll have those radio frequency spectrum. You have the analog TV, you have the UHF, VHF, digital TV, and then you have the cellular network. So for those that are going lower, if you remember this formula, C equals C over F. So the wavelength would be inversely proportional with the frequency. So the frequency, the higher the frequency, you have lower wavelength. Lower wavelength would be more susceptible to fading. So with that, it only goes as far as this compared to the low bands because you have lower frequency, so you can go beyond. So it's like AM FM, right? AM is mas napupunta sa probinsya because it can go to the ground. It propagates to the ground, and then FM higher frequency it can go as much as this. So ganito din, if you can apply for those non-telco people. So MBB connection prefer higher band, and then avoid low bands is only for coverage because the low band usually is used as a net. It gets the user because it's bigger, so it gets the user. And then if it what do you call this? It reach the target. I mean, if it's still within the target of the signal level, it can give it down or give it up to the higher band as a capacity layer. So may ganung implementation before, and I think it's still valid now. Is that the mobile broadband usually are more static or they're not moving kasi mobile broadband those one using a module a card using for laptops as is tethered on the laptops and they're more stationary, so you can be given to those smaller cell but you have higher bandwidth and higher coverage, and still the low band still getting all the cells or catering for those that are in the fringes or the uh, coverage edge. So here in the traffic steering, it identifies your bearer and it decides where you're going. So voice calls goes to the low band. If it depends on their policy, ah. So hindi naman siya hardcore na dapat ganon, but usually ito yung best practice. So voice which is covered by B, cell B, goes to the cell B, goes to the with the low band, and then for the MBB it goes to the higher band if it detects that it's using broadband. So you can define it here in the policy, guiding the near real-time rate for its decisions. So policies for allocation of CP, CP is control plane and upper plane, okay, upper plane, user plane for different services identified by 5QI are sent to any cell of concern. Example, where the UE resides and may move. Okay. Next. Okay. Any question po muna doon for traffic steering? Cons for low bands, must be higher CSS failure and higher utilization. Yes po. Kasi po, since it's low band, siya talaga unang pinupuntahan ng ano. If UE is to decide on itself, I'll go to the low band because siya yung una kong makikita kahit malayo ako sa site, even if I'm far away from the site. But since you have the policies, you can define priority levels. So that's why usually the priority levels are set to higher for higher bands. So that even if the low bands, the measurement for low bands is a bit higher than the higher, usually if you have the phone and you measure it yourself, low bands will get the higher signal if you're away from the site because nag-fade na yung higher frequency eh. But since you have the policy to set the priority for a higher band, if still meets the criteria or the thresholds, even if you have good low band, if you can still see the higher band with this threshold, let's say priority for higher band is highest priority until up to the point that I'm still neg 98. Okay, as long as as long as I can see that higher band is neg 98, and then I can see that the low band is neg 95. So basically, kung phone lang yan, I'll go for the neg 95, right? That's low band. But if you set a priority for higher band, even if you're 3 dB different from the low band, and you set the priority for the high band, the phone or the UE or the terminal or the AP would still choose the higher band based on the policy. So yun. But yeah, in real world, even if you set the policy higher band, still set the policy the priority higher than the low band, UE tends to go still to the low band. Yeah. So, yun nakaka-problema yung sinasabi ni Sir Gilbert that's why minsan hirap mag-steering. In the traditional run, as an I think some telecom professionals here would agree that it is very hard to steer the traffic because may sarili silang topak. I mean, may sarili, they you don't really know. You can only be having an educated guess based from the KPI you're getting. So you're setting this parameter, you're setting the hysteresis so that you can steer the traffic, but you can do as much with that. And then someone pointed out about the tilt a while ago. So you can also change the tilt to see if, for example, if the low band is already overshooting, you have to down tilt it so that it can be given to a different cell already. Okay? Kasi if it's getting more UEs and it's being congested, you can steer the traffic. But you're doing it manually. It's not very intelligent. It's very time consuming. But with the AI, ML, and all these policies that you can define and giving it a training data, Open RAN is promising that it will be more intelligent and more agile for this. Okay, so let's go po for any more question for that one use case. So, yung po sa mga kilala ko dyan na problema with traffic steering, maybe would be a better days for us for this use case, for the first use case, if it's more intuitive. For it will be easier for us to optimize. Okay, where to set the policy? It's in in the real time. RIC. CP-UP? UCP-UP. Hindi po. As control plane and user plane is on the communication. Okay? The policy, you define it on the RIC, and then how it communicates it is via the control plane. Okay? Masali para sa traffic na mag-flow sa natural behavior kasi sa protocol system. Yeah. Opo. Pero kailangan silang turuan. They have to be taught na ganito because we have to maintain a network, yeah, a good KPI. So yeah, mas madali nga natural behavior. So, but you know, in my opinion, it also goes back to how good it was planned. Tama? I think baka po may planners dito, huwag niyo ako awayin. But it is still based on how good is the plan in the first place. Because if the plan is not that good, kawawa po yung mga go-optimize. And we can do as much as this for them na para pasunurin sa gusto natin. Okay? So, yun. So, kung meron pong mga nagplano tapos magkatabi yung site, 300 meters away lang. So, magkakaroon talaga ng interference yan. So, mahirap talaga. Okay, QoS-based optimization. So, pasadahan lang po natin itong mga UE test cases natin. Ito kaya UA use cases. Next. So, yan. Napag-usapan natin kanina yung QoS. So, basically, we're doing decisions based on the quality of service. So, we have different quality of service. Guaranteed bitrate. Guaranteed bitrate, ito yung mga voice call, yung hindi pwedeng napuputol. Kasi kung may ma-retest ka, dapat tuloy-tuloy yan. So you need to have a guaranteed bitrate. Okay? Non-guaranteed bitrate would be for packets like data. So hindi naman, although you're having sessions, tuloy-tuloy yan, but at the background, hindi yan tuloy-tuloy talaga. May schedule yan. So it's not guaranteed bitrate. So may times na you have to have this bitrate, may times naman na kailangan mo pahinga. Okay? And then give it to others. Okay? So that's the non-guaranteed bitrate. This is for the traditional RAN. Existing na to sa traditional RAN. Ano to? This one. And then with the advent of the 5G, this is added the delay critical. That's why 5G is promising ultra reliable low latency. Okay? Because you need to have this delay critical guaranteed bitrate. So, bukod sa voice, may mas mahalaga pa pala. Those are the delay critical GPR. So, what is this telling us about? So these are the 5QI table. For the LTE, you have the CQI table. You have this CQI. Basically, it's just the LTE CQI, and then some have additional because of the 5G, especially for the delay critical GPR. Let's see, there's a pointer. Delay critical GPR. So you're just setting the priority level. So here you can see priority level for a while ago, we have the 67. Ito pala, 67 is a mission critical video user plane. So you have packet error rate of 10 to the negative 3, 100 milliseconds, and then priority level of 50. Mission critical push to talk, we have 7. And then ito, makikita nyo dito that you have a maximum data burst of here. You're guaranteed this. You know, this delay critical is not byte extensive because delay critical GPR is not like downloading a video. Okay? Kunyari, may gusto kang video, napapirate ka, da-download mo. Ang tagal, no? I mean, is part of the eMBB. But for the delay critical GPR, you're sending like critical information that needs to be decided immediately. So you need to guarantee this kind of bytes. So for example, ano ba mga sa mga autonomous driving. So immediate information feed by the car should be sent without delay. Or for example, isang promise din kasi ng 5G is yung pwede ka yung may mag-ooperate remotely. Wala ka sa table, operating table. But for example, may isang expert or may isang specialist, they cannot go over, but he knows how to do the operations. So it can be remotely done. So it has a delay critical activity. So it needs to be here. So what it's telling is that it's giving priority levels on depending on the usage of the bearer. So our challenge is instantiation of RAN subslice is prepared by careful planning to understand if RAN resources will be able to support RAN subslice LSS. Default behavior of RAN is obtained that shall fulfill slice SLS in most situations. Network slicing, if you can Google it, or it's mostly now with the advent of 5G, we can prioritize usage. Dati kasi we have either you can use it for parang we're all sharing, but now with the network slicing, you can really reserve depending on who's using it or on what application is being used, okay, or what company, maybe a certain person, a certain entity needed this information. So scheduler ensures PRB isolation between the slices and uses PRB in optimal way to fulfill SLS for different slices. Okay, there are times and places where RAN resources are not enough to fulfill SS, the default configuration. Okay, aims of objective, monitor performance of RAN slice by SMO to understand how often and where RAN resources are not enough to fulfill SLS using default configuration. So same as with the traffic steering, the decisions now are based on the QoS. Okay. Provide QoS-based resource optimization to be used when network is configured to provide we call this provide preferential QoS for certain UAs. Yan. Preferential, that's a term. QoS, for example, network is configured to support E2E slice and has to ensure resource isolation between slices and monitor fulfillment of the slice SLS. But SLS is like a service level agreement, okay? It should be performed in this way, or how fast it can be fulfilled. Okay, so you can set the slice based on the QoS being used. So realization detecting when RAN SLS cannot be fulfilled and use non-RT RIC AI policies to improve situation. Yan. Non-real-time RIC uses additional information for SMO to understand how to utilize AI policies and how to resolve situation. desired default run behavior is configured over O1 interface. Example, ratio of PRBs for a slice, QoS to guide schedule and how to allocate PRB to different users or resource partition. Okay, so kanina our training data would be the level quality, but now you have the QoS to guide our network how it makes the decisions. So required data, ito pala, resource consumption and area. If low run scheduler provides all users needed resources, when high above threshold, default configuration is enough, thus non-real-time reconfigures detailed reporting for individual UEs. Detailed observability giving insight in performance of specific UEs, that is UE throughput and delay. So it now looks into the actual throughput for an individual UEs. Dati, level, quality, we're looking at that. PRB is physical resource block used in LTE and NR. It's basically like a channel, a resource. Okay, so pag gumagamit ka, pag nagda-download ka, o gumagawa ka ng multi-calls, you're giving a PRB. Next. Okay, yan. Okay, you have the slice. QoS-based, resource-based organization ensures resource isolation between slices and assures slice fulfillment. Okay. So katulad kanina, dito lang din yon, monitor. Same. Basically, you have here the network function, the policies for near reality to drive QoS based on optimization action level. Here, it supports interpretation, execution of AI policies. So, nagbe-base pa rin siya sa policy na din-declare mo. And then, execution pa rin is with the nodes. So, katulad yan, high priority users, 10 and 12 is high priority users. So, it is given more compared to the 11, 13. It's not that yun, it is not that hindi to parang pagiging racist sa mga phone. It's just that may mga phones that you're just needing this kind of pipe. Okay, so you don't have to use the entire pipe. So you have to, for example, sa isang you're in a EDSA and then there's an emergency ambulance. Ano yung ginagawa nyo? Tumatabi kayo. Kahit na hindi ka na makagalaw, tatabi ka pa rin, di ba? Kahit sikip na. But you make it a point that ang una mong gagawin is tumabi or to set aside a space for the ambulance to get through, because that is a mission critical vehicle. Okay, so it's the same thing. So you're defining high priority users, and then you schedule. So mas mahalaga ka, so you schedule a better resources here. Okay, and then run sharing. I'm not sure if it's being done here in the Philippines, but there are some countries that are using site sharing. I think what's happening in the Philippines are more on civil infrastructure. It's an X deal. I remember even in 2G, one operator will have an X deal with a different operator to share a tower. Before, may ganyan. So if papayagan kita ilagay yung site mo sa akin, bigyan mo ako ng isa ring site. Ganyan. So lalo na kung ang hirap ng site act. May site act po ba dito? Hello. So if there's some site act, isang hirap mag-avail or kumuha ng isang site. So ito, wala tayong choice to share. So you have the site sharing models. You have a site sharing, meaning hiwalay pa rin yung network, but infrastructure kasama lang kayo. Okay? So run sharing or MORAN, multiple operator radio access network, meaning you have different core RNC, okay, you're sharing, but you have different frequency. Okay? So you have a single yes, you have a single site, you have a single hardware, but iba yung bumubuga. This is being done in New Zealand. I have experiencing this one. In New Zealand, there are MORAN. So may isang network doon na naka-MORAN with another network. So bumubuga yung isang network A and then bumubuga sa network B. So as a subscriber, you don't know this, but you think that you are having the two different operators. but not. They're sharing. So this is cost effective for one operator. And another revenue for the operator who is hosting. Kasi may host yan eh. May talagang may-ari niyan, nakikisakay lang yung isa. And then you have the MOC-N. Okay? So basically, you have shared elements, but you have a single frequency. Okay? This one is being used also for New Zealand, but more on the rural. This is like a government. Ako may-ari nito, akin ang frequency, akin lahat to. But pwede kayo makisakay, different core network. Okay? So like yan, operator A, operator B. Ang nagagawa pa lang natin dito is common tower, which is yan. Maybe a good move forward for this. Okay? And then, can we maximize assigned space? Yes. So, basta may separation niya, it can be doable. This is size sharing. Facilities lang yung pinag-sharean nyo. Antenna, yan. Pwedeng isang antenna, but you need to have combiners, triplexers, so that different network pa rin mag-share. And then you have the MORAN, the MOC-N. MORAN, yan. You have two frequencies. Okay? Dalawang operator pa rin. Or you have one frequency, but you can go to different core network. Okay. Main limitation for site selection is RRU power. Yes, because paghahatian niyan, dalawa. And then this one, main limitation for site selection, PRB. Because, for example, yung lahat ng operators natin is a frequency. Hindi ay labo-labo kayo dyan. Usually, this one is being used if it's very low utilization in the area. That's why in New Zealand, they have this RCG network, Rural Connectivity Group, wherein the government owns this. And then, konti lang naman kasi yung tao sa rural area doon eh. Siguro mga kangaroo ba doon? Ah, hindi, sheep pala yun doon. Puro sheep lang pala, tapos may dalawang tao. But they still need the connectivity. So, hindi niya hindi niya mauubos in terms of frequency. But the 3-4 networks can join in. Okay, babayaran na nila yung gobyerno. Pero that is still mura ha. Mura pa rin yan for the network because wala ka na nito eh. Okay? Babayaran mo lang yung gobyerno. So, more on use case in Open RAN. Here, the thing with Open RAN is that you can visualize. So, everything is shared. And you can, in cloud, meron ho ba mga cloud practitioners dito? In cloud, you can readily create DNF or virtualized network functions. So, you just create your own OCU and ODU on the cloud, right? You don't have to roll it out physically, right? RU na lang yung nandoon. Okay? So, you can share and then define it, create your own instance in the cloud for this one. As long as you have, of course, you still have to have these interfaces to communicate. A key here in networking is synchronization. You need to be synchronized in everything you do. Massive MIMO, also a use case. I think kanina sinasabi natin directional yung antenna, diba? It's a directional. So in a massive MIMO, you can have multiple input, multiple output. So that's you can have more you can serve more UEs. Okay, because here in a traditional basic antenna, you can have directional, more radiating element. Okay, pag ito lang yan. Okay, and that's why someone is asking about the Omni. Yeah, you have to have more gain is to have this radiating element more, because more gain means layo na narating. Okay, and serving more UEs. But it's being more directional. Ayun lang. May mga trade-offs and but we want this. Okay? So that you can, mas madaling kasing timplahin to eh. You can move it here, down till here, down till there. Okay? Multiple beams, beam forming. Okay? You can form, you can have these phase shifters to move it. So basically when you're doing beam forming is, nakita yung kanina yung buga ng antenna, the propagation, you have the flexibility to move it around with this. And then if you have the massive MIMO, for example here, you can have this like 1 in 92 elements. So number of antenna elements define the antenna gain, which controls coverage. More antenna element, give more coverage, and such. So ito yung mga nakikita nyo yung antenna sa 5G na parang laptop na lang sa taas. Kasi yung form factor niya maliit. And it defines, ito yung formula na sinasabi ko kanina. So wavelength, speed of light, and then the frequency. The higher frequency, that's why you're using higher frequency so that you can have smaller form factor. You know, yung mga nagbibuild dyan ng computer, you know the form factor, right? So because if you have lower frequency here, like for example 900 megahertz, edi isa kada pinto na in laki niyan, and it will be very difficult for the civil engineers to put it there to make a tower exclusively for that. So that's why we use a higher frequency so that you can have more elements here. And then beam mobility management, here, massive MIMO, it will help us direct the antenna efficiently. So you have these three types, these three use cases. Non-RT beamforming, wherein you're telling the beams where to go. And that's from the training data, from the UEs, ng saan ba? Kasi if you have the site here, the massive MIMO BTS here, and the concentration of people are here, so you're training the network to direct the beams here. Para, ba't ka magdidirect yung beam? Puro sementeryo pala to. Okay? Unless may biglang nag-party-party sa sementeryo, then you will train the network na, may tao na uli dito. So you direct the beams there. Or not the entire beams, some of the beams there. You know? So unlike before, you have, you're setting it manually, but now you have the intelligence here. And then here, the near RT beam-based mobility robustness optimization. And here is more of the UE deciding, okay, based on the UE. So it's sending the measurement report, and then based on that, it tells the UE where to come, okay, based on the beam directed towards it. And next, okay, may nagtatanong kanina sa antenna. It's an active antenna unit. So, may open beam. So, part pa rin if you have this, but if, for example, you're the traditional transducer antenna, not much to do with that. But here is a different thing. Ano bang, ano nito? These are Mavenir. Yeah, another vendor. And then the UAV, so this one yung mga non-terrestrial network, yung mga lumilipad-lipad, telecommunications, weather sensing. So because these are like UEs, they're moving. And ang problema, UE, at least yung UE hawak nyo. UE is with you, but the UAV is it's moving by itself, and it needs a constant connection with the network. So this one is one also use case that it gives with the massive MIMO, because it can track down the UAV so that it will not be lost. So sino ba diyan taas po ng kamay, mga nag-drone? Meron kayong mga mini heart attack pag na-disconnect yung controller with the drone, and pag di na nakipag-communicate yan, bahala na siya hanggang maubos ang battery and it goes down. So you need to have this. One example is the high altitude platform station. It's a network node that operates in the stratosphere at an altitude of 20 kilometers and is instrumental in providing communication services. So mas mababa to sa Starlink. Starlink would be like somewhere above here. So it's also an option. And it's being driven by massive MIMO. And it needs a constant, connection with the network. So how be part of the Open RAN? So the same, you can see here the architecture, and it's constantly sending data for it to have all the decisions optimized for the UAV. Okay, so summarizing this, the main goal of the European operators participating in the Open RAN MOU is to, memorandum of understanding, is to direct and encourage the development of a non-fragmented open ecosystem and vendor's roadmap while ensuring the open achieves parity with best-in-class conventional technologies. Keyword is non-fragmented because the danger of openness is that watak-watak tayo, may kanya-kanya, basta ako ito, basta ako ganyan. So even if you're open, it should not be it's not be fragmented. It should be unified in a certain specification. That's why you have the technical specification. A use case that makes use of ORAN architecture and exemplifies its special advantages is called an ORAN use case. That's why. So, keyword here would be AI and ML. Yun ang wala sa traditional LAN. The ability to use machine learning systems ay ito pala. Okay? Artificial intelligence backend modules enable network intelligence through open and standardized interfaces in a multi-vendor network is one of the key advantages of ORAN architectures. Yan ang sasabihin niya kay traditional LAN. Wala yan sa lolo ko. There are two phases of ORAN use cases. Phase 1, ito, mga diniscuss natin. And then the UAV kanina would be the phase